All right, so let's look at the energy stored in a capacitor. This is a lot of the use of capacitors is used for this. Like people will use them for pulse lasers or camera flashes. Basically, we just want to store energy in them. Now, there's a 1/2 on there, and it's a bit like, remember springs are, the energy in a spring is 1/2 kx squared. It's just like that. It's really a very similar thing. And the reason the 1/2 gets in there is that if we charge this thing up to some final voltage, the average voltage that we charged it at is, because it starts off with no charge on it, there's 0 voltage, right? So to put the charge on it first is easy. The more charge we put on, the harder it gets. On the average, the pressure or the voltage resisting us is, the average voltage is just 1/2, whatever that final voltage is, right? Now remember that what potential energy is charge times voltage, right? Charge is, remember the derivation, the definition of capacitance is Q over V. So Q is CV, right? So I just substitute CV for that. Right? That's the charge that I've got on there when I've charged it to this voltage. And then the average voltage that I charged it at was 1/2 V. And of course, if you put that together, you get that the potential energy is 1/2 CV squared. Just like a spring. In fact, it's sort of the analogy, the electrical analogy of a spring. And springs are used to store energy as well, right? Okay, so let's do the example problem here. All right, so we're going to do E is 1/2 CV squared, so it's going to be 1/2 4,500 times 10 to the minus 6, that's microfarads, right? Times 6 squared. And that gives us 0.081 joules. There we go. All right. I might do another video. There's actually, what's cool about this, right, is that the capacitors, if you imagine this, right, they store the energy in this electric field. If you can just imagine this electric field in there. Electric fields themselves require energy to create. And the energy of a capacitor is actually stored in that electrical field. And this is the energy density of it, which is kind of cool. But anyway, I'm just going to sign off for now because I know you probably aren't as excited about that as I am.